Welcome to our channel Quaint Cosmos. Today's topic of discussion is how beta decay changes the composition of a nucleus. Yes, this is a topic chosen from the field of nuclear physics, and this is actually very easy topic, very simple topic. Okay, just if you study the basics of nuclear physics, so there you would find this topic. So what is the topic? Topic is how beta decay changes the composition of a nucleus. So I think it is already known to you, beta decay phenomenon. So let us first consider what is nucleus. So we know that at the core of any atom there is one nucleus. A nucleus, this is made up of protons and neutrons. So if there is any instability, means if the nucleus is unstable, in that case there is a phenomenon of beta decay. Beta decay is nothing but a type of radioactive decay. Say, in the nucleus, number of protons is more than the number of neutrons. So there is a question of, there is a problem of instability, means instability. Okay, means the nucleus is unstable in that case. So due to the presence of the force, I am talking about weak nuclear force. This force is behind such decay phenomenon. Decay phenomenon means I am talking about beta decay. Okay, beta decay here, beta decay is nothing but emission of electron. Okay, beta decay is happening. That means one electron is emitting. Of course, when it is beta minus decay, there are two types of beta decays. One is beta minus decay, one is beta plus decay. So in case of beta minus decay, there is an emission of electron, and that electron which is negatively charged, that is known to you, that is called beta minus decay. Or a beta particle is decaying or emitting from the nucleus. Okay, so anyway, I was talking about what? I was talking about if the nucleus is unstable, in that case, what happens? This beta decay phenomenon happens. Okay, and that way the element changes from one form to another, such as the atom was fluorine. Fluorine, this name is known to you. And after this transformation, after this beta decay phenomenon, okay, what happens? Fluorine becomes oxygen, right? Again, carbon-14 is there. Carbon-14 becomes nitrogen-14 by this radioactive decay phenomenon or beta decay phenomenon. So what happens? I have already mentioned that two types of beta decaying is there. One is beta minus decay and another one is beta plus decaying. So in case of beta minus decaying, what happens here? Number of neutrons is more than the number of protons in the nucleus, inside the nucleus. Okay. So here what happens from the nucleus? Here actually what happens? The neutrons, the one neutron here is transformed into a proton by emitting certain things. Which are those things? One is beta particle, another one is antineutrino particle. And this happens due to the presence of the force, weak nuclear force. Okay. Generally, inside the nucleus, protons and neutrons are bound together by the presence of the force which is known as strong nuclear force. But this phenomenon, beta decaying, this happens due to the presence of weak nuclear force. So when suppose we are talking about carbon-14 atom. Okay, so there is a number of, in case of carbon-14 atoms, 6 numbers of protons are there and 8 numbers of neutrons are there. Okay. So what happens here? One neutron is transformed into a proton. So that way number of protons becomes 7 and number of neutrons becomes 7. Final result, neutrons becomes protons after emission. of a beta particle and an antineutrino particle. And that way, the carbon atom becomes transformed into a nitrogen atom. C14 becomes N14, that way. Similarly, in case of beta plus decaying process, in that case, number of protons is more than the number of neutrons. Just the opposite of beta minus decaying process phenomenon. Okay. Number of protons is more than the number of neutrons. So there in that case, proton is transformed into a neutron. There also emission takes place. Okay. Emission of not electron but it is positron, means a positively charged electron and one neutrino particle. And in all the cases, so here as an example, we can take the example of a fluorine 18 atom. Okay, fluorine 18 atom becomes oxygen 18 atom after beta plus decaying process or phenomenon. Okay, so both happens. So in the study of nuclear reactions, you would find all these things, and there is an application of this such as for the age measurement of fossils, like that. So here carbon dating, okay, this process is used. Anyway, I am not talking about the application area of this. Yeah, I was just talking about the transformation due to this beta decaying phenomenon. Okay, and what? I think I have already finished talking about each and every aspect of this beta decaying phenomenon. And alright, one more thing is there. What is that? Here you can see neutron becomes proton, proton becomes neutron, but in all the cases, and other emissions are there, in all the cases energy is conserved, mass is conserved. And to verify this, you need to use the formula E is equal to mc square, Einstein's this mass energy equivalence formula. Otherwise there will be discrepancy in your calculation. Okay. Anyway, so this was all about the topic. Okay, so this is the end of this video. Thank you for watching this video.